All right, in this video we're going to talk about how to create and apply sample weights manually. And the scenario that we're using is one in which I know that the population that I'm working with, 90% of the people have red as their favorite color, and 5% prefer blue, and another 5% prefer purple. Based on this assumption, I did something. Maybe I gave a presentation or something and made most of it red, knowing that most people liked red. And then afterward, I asked people what their satisfaction was with that presentation that I created in red. So the data that we're going to work with is this simple data where I have 20 different respondents to my little satisfaction survey. And I have them identify their favorite color, which is either red, blue, or purple. And you can see I have that variable twice, once in a factor format where I can see the actual label of the color that they prefer, and once in a numeric format where I just have codes, where 1 equals red, 2 equals blue, and 3 equals purple. And then for each of these people, I also asked their satisfaction with the presentation. And you can see that, in fact, the people who liked red were much more satisfied. 5 is a high satisfaction. People who liked red were much more satisfied with the presentation than people who liked blue, and the people who preferred purple were sort of somewhere in the middle. So if I summarize this data, we can see that my mean satisfaction level here was 2.5, which isn't super meaningful because this is an ordinal scale and not an interval scale. But I also recognize that this is a lot lower than I was expecting, especially because I think that 90% of my population prefers red, and they all really liked the presentation. They all gave it a 5. And so what we want to do here is create some sample weights that will show us what that satisfaction variable would have looked like if the population had been distributed the way that I expected it to be, if my sample had been distributed the way that I expected my population to be. So I can see here in this summary of my factor variable that in the actual sample, 25% of the respondents preferred red, 25 preferred purple, and 50 preferred blue. So we're just going to sort of make note of that over here. We had a 25, 50, 25 distribution. Okay. Now, because I know what the distributions are and I know what the distributions should have been, or what they were in the general population, I can create sample weights based on those numbers. So the sample weight for red should be 0.9 for 90% divided by 0.25. That gives me the proportion in the population divided by the proportion in the sample. I'm going to do the same thing for blue, which is 0.5 over, 0.05 over 0.5. And then for purple, we have 0.05 over 0.25. Now I want to apply these sample weights, and I'm going to do that by creating in R a new variable that is a sample weight variable. So the way that I'm going to do this is I am going to use the recode option under Edit Data, and I am going to recode the numeric version of favorite color. So everything that was a 1, which was red, I'm going to change to the red sample weight. Everything that was blue, which was a 2, I'm going to change to the blue sample weight. And everything that was a 3 for purple, I'm going to change to the purple sample weight. And I'm going to call this new variable weight. And I don't want that new variable to be a factor. So all my 1s I want to recode to equal 0.9 over 0.25. All my 2s I'm going to recode to equal 0.05 over 0.5, And all my 3s I'm going to recode to be 0.05 over 0.25. So now if I apply these sample weights, there should be a 0.9 over 0.25 weight for all the reds, a 0.05 over 0.5 weight for all the blues, and a 0.05 over 0.25 weight for all the purples. This new variable with these sample weights will be called weight. So I'm going to go ahead and do that. And the next thing that I want to do is compute a new variable that will give me my weighted satisfaction. So I'm going to do a new variable called W underscore satisfaction. And the expression that I'm going to use to create that new variable is weight times satisfaction. So I can either type those in or double click the variables over here. So what this will do is take each satisfaction score that somebody gave and it's going to multiply it by the sample weight. If I view the data set, what I'll see here is not only that I do in fact have the weights put in here as expected, but I also can see these weighted satisfaction values. Now these individual values, these 18s and these 0.1s and these 0.6s, don't actually mean anything by themselves. But when we aggregate all of this into an average, it's going to create a weighted mean or a weighted average. And what it will basically tell us is what the mean would have been if the sample had actually been representative of the population and distributed along red, blue, and purple the way that our population actually was. So let's go ahead and rerun that summary to find what we see. All right, so the two variables that we're going to look at here are satisfaction and weighted satisfaction. So remember that our mean value for satisfaction was 2.5. And that was in the scenario where our sample didn't really represent the population. There are a lot more people in the population who prefer red than there were in my sample. So when you look at the weighted mean, that is a much higher satisfaction level. In fact, it's much, much closer to 5 overall. So that 4.7 is what I would have expected the mean satisfaction to be if my sample had actually been proportioned in the way that the population was proportioned.